Today I'm going to talk about the Mössbauer analysis of metallurgical slag sample. In this presentation, I'm going to talk about all the sample that we measure X-ray diffraction and Mössbauer spectroscopy, including at room temperature and at 50 Kelvin. Well, the sample that we work in this that I measure in this presentation, or I will present to you, is the sample type 1, type 2, type 3, 1, 3, 2, and type 4, and then chips type 2 and chips type 4. The characterization of techniques used in this presentation, well, today I'm going to talk about only X-ray power diffraction using cobalt alpha radiation source, and Mössbauer spectroscopy measured at the room temperature and 50 Kelvin. I'm going to start talking about the sample type 1. In this case, I show you the X-ray pattern showing the magnetite as a important or principal crystallographic phases. It is because this sample contain, or this phase contain iron as a principal element. In this case, we identify CONCYTEC, another crystallographic compost. Yeah. But when we measure Mössbauer detect not only, or Mössbauer revealed not only magnetite as revealed as a principal or in major area, two doublets. These two doublets at when measured at 50 Kelvin, these two doublets are present. But in this case, we observed hematite as a magnetic phase revealed by Mössbauer spectroscopy. In this case, hematite was not revealed using X-ray pattern. It can be explained because there are many peaks in this case. There are many peaks, and we can not observe because an overlapping can be shown in this case. Well, by the sample type 2, magnetite and other phases, including gustite, were identified. In this case, at room temperature, gustite non-stoichiometric is shown by the presence of these two doublets. Side A in green, side A and side B in green here. And we identified magnetite as one of the phases present in this sample too. Yeah. In this case, it was identified calcium 2, iron 2, oxygen 5 as identified by X-ray diffraction, and in this case, identified by Mössbauer spectroscopy 2. Well, in this case, we don't have a measure at 50 Kelvin. By the type 2 sample reduced, we have as a principal phases magnetite, calcium 2, iron 2, oxygen 5. Well, this is the phase identified before the type 2 was reduced. And in this case, for the reduced sample, we identify alpha iron. In this case, alpha iron as a principal phase, and the presence of the in this case, we do not observe the presence of the gamma iron. Well, when measured at room temperature, this sample we identified alpha iron, a typical sectic discrete sextet of alpha iron, and the presence of a doublet and a gamma iron. In this case, we don't identify what was the element or the compose that represent this discrete sextet. Well, we are working about this sample. Well, in the case of that sample 2 chips, we identified only alpha iron as a principal phase by the X-ray diffraction using a cobalt radiation source. We have measured at room temperature and 50 Kelvin. In this case, at room temperature, we observed the typical sextet for the alpha iron. In the case of the 50 Kelvin, we can observe variation on the hyperfine field and the width of the peak in each of case. Well, but in this case, it still alpha iron phase 2. When we talk about the sample type 3.1, we observed we have in these cases X-ray diffraction pattern in log intensity and normal intensity here. We observed all these crystallographic phases. When we measure this sample at room temperature using Mössbauer spectroscopy, we observe augustite as one of the principal phases, revealed by these two doublets. The presence of the magnetite is revealed by these two doublets, and in this case, we observed hematite phase as a phase. All of this sample was revealed by X-ray diffraction pattern 2. Well, in the case of that sample type 3.2, we identify all of these samples. In the case of calcium 2, iron 2, oxygen 5, gustite, non-stoichiometric gustite, and hematite, and is calcium iron, silicium oxide 4. All of these samples were identified too using Mössbauer spectroscopy, including when we measure this sample at 200 Kelvin. All the phases were identified too are at 200 Kelvin. In the case of the sample 4, in this case we show for you all the X-ray pattern using the spacing and 2 theta degree. In all of cases, in this sample, we identify gustite, magnetite, and hematite as a principal phase. Well, this sample was measured using cobalt and copper alpha radiation source. In the case of the Mössbauer spectroscopy, for this sample, we identified the magnetic phases identified by the X-ray diffraction are in accordance with the phases revealed by the Mössbauer measured at room temperature, showing a gustite, non-stoichiometric gustite, was two sides of the phases, two sides of magnetite and hematite. Well, when type 4 sample was reduced, we observed alpha iron as a principal phase, observed gustite, non-stoichiometric gustite, and magnetite. In this case, we show here in normal intensity in low intensity. In this case, we can observe as with better resolution the presence of the iron 3 carbon and carbon. When we measure the Mössbauer spectroscopy for this sample, we can observe all the crystallographic phases revealed in the first case: alpha iron, non-stoichiometric gustite, magnetite, and we can observe too the iron 3 carbon. If I don't remember, as is cementite. Okay, well, in the case of the type 4 chips, only we can observe in this case for the X-ray diffraction pattern only the iron gustite and the alpha iron phase and the non-stoichiometric gustite. This was corroborated using Mössbauer spectroscopy. In this case, in the Mössbauer spectroscopy, we observe alpha iron with a principal, as a principal phases on the Mössbauer spectroscopy, and two doublets corresponding to the non-stoichiometric gustite. Well, as a conclusion, from the X-ray diffraction measure, well, we identify all the crystallographic phase for all samples, and it was possible to identify and characterize and analyze the iron magnetic phases using of each of sample using Mössbauer spectroscopy technique. Well, that's all. I would like to thank the CONCYTEC, the World Bank, and the Fondiset Prociencia for this project. Okay, that's all.
Okay, thank you very much, Marlon. Questions? Narciboya has questions?
Hello. Yeah, it's okay. Good, sir. So actually, you are given type 1, type 3, type 4. So what basis you are given that names, and what is the reason behind that? Any specific? Yeah, slide 2.
Each sample can one.
Yeah, 1, 2, 3. So
1, 2,
3, 1, 3, 2. So how you are given? So any behind reason is there?
The reason is because one of the sample is related to the process of the fabrication okay.
From process you are taking sample.
Yes, from process.
Okay, different process you are giving names just like.
Yes.
Okay. So chips directly collected. Okay, good.
Okay, any other question? Pratap Kolu? Pratap? Professor Pratap Kolu, your microphone. Pratap is sleeping, I think. Pratap. Okay, no Pratap here. Any other question from other member? Questions? Maybe in Spanish. Preguntas para Marlon, aprovechando de sus trabajos que tengan, quizá. Sus trabajos que están pendientes, algunas preguntas que quedaron. Quizás los árboles estén diciendo algo, están pidiendo algo y Marlon puede aclarar acá. A ver, preguntas de una vez. Renato Luis Borja no tiene ninguna pregunta a Marlon, ¿no?
No tengo pregunta.
Maricel, ¿preguntas?
Todo claro.
Chévere. Okay, thank you very much, Marlon, Valerio. You can stop sharing your